Welcome to week 9, day 3 notes. This is the last day of notes of the school year. So congratulations on doing well for the last 9 weeks. And our last day is going to be continuing to practice using our acronym SHRATEY to analyze rational functions. But today the ones we are going to see will simplify, and so they will have holes. And so the analogy that I usually make to my classes about having holes in the graph and why they behave the way that they do is if I took a graph, let's just say I gave you, a normal graph like that, and I placed a vertical asymptote in that graph. Then what that vertical asymptote is going to do is let's just say it was right here. What it's going to do is it's going to take my graph and it's going to divide it. It's literally going to cut it apart. The two branches of the graph are going to begin to behave differently. So my graph might, do something like this. And so they're going to split apart at that vertical asymptote. So the vertical asymptote literally is a cut, or even if you want to take it so far as to call it a wound in the graph. Literally makes the two sides of the graph pull apart from each other and separate and do their own thing and behave their own way. Okay? When you have a graph that you are able to remove the vertical asymptote from, and so you are able to factor your equation and reduce it and make it go away, then it's essentially the result of healing that wound. And just like any other wound that heals, if you're able to heal the wound, then what it leaves behind is a scar where that wound would have been. So now there would be a little hole right there. And so the hole, a couple of things. The hole can't occur somewhere random out here. I mean, the graph didn't exist there to begin with. The hole is left on the graph, just as if you cut your finger open with a knife or something when you accidentally cooking or something. When the scar heals and it's left behind, it's left in the spot on your finger where the cut occurred. And so the hole is left behind on the graph of your function where the cut would have hit it, okay, or would have made it separate. The other thing about a hole is that it's a point. It's nothing more than a hollow point. And in order to plot a point, you're going to need to find the x coordinate for that point and the y coordinate for that point. And so we're going to have to talk about the steps to find each of those because they are found in different steps. Okay, so let's go ahead and look at our first example. So here's our first equation, 2x minus 4 divided by x squared minus 3x plus 2. Okay, and so I'm going to do my SHRATEY steps just like I did on day 1, but of course this time I'm actually going to have some simplifying to do. So I look at my numerator. My numerator has a greatest common factor of 2, so I factor that out and it leaves behind an x minus 2. And then I look at my denominator. My denominator also factors. It factors as x minus 1, x minus 2. And so what I see is that I do have a factor on top that is also on bottom, and so that factor would reduce out of the equation. It's gone. And so now I have 2 over x minus 1. There is my simplified equation. The first thing that you need to make sure you understand is that once the equation is simplified, we do every other step with the simplified equation. we do not ever revert back to the original equation at this point. Okay? So step S, the first step, we simplified our equation. The result is that we are going to have a hole right there on our graph. So the reason that the hole is there. Okay, so now it's time to locate the hole and understand why the hole occurred. The x-coordinate for the hole is right here where this vertical asymptote would have been. That vertical asymptote, or that cut, if we had not been able to cancel it out of the equation, would have been at x equals 2. So the x-coordinate for that hole is 2. Okay? But then we have to calculate the y-coordinate for that hole. And the y-coordinate for that hole is a lot more straightforward. The way that you find the y-coordinate for any point is you take x and you plug it in. And so to get the y-coordinate for that point, we are going to plug our x value, x equals 2, in, and we're going to plug it in to the simplified equation. Remember that once we've simplified our equation, everything else gets done with the simplified equation. So if I took 2 and I plugged it in for x into the simplified equation, I would just have 2 over 1, which is 2. And so that's why the y-coordinate for that hole is also 2. And so my hole is at the point 2, 2. Okay? From here on out, the rest of the process is just like we did on day 1 of this week. Now we can do the analysis steps, okay, to analyze the rest of the graph and its behaviors. So our R step says to take the numerator and try to set it equal to 0. Well, our numerator now is just a constant. That numerator, it can't equal 0. There's no variable to solve for. And so what we get is we get no solution. And so that means we have no x-intercept, which you can see on your graph. That graph never crosses the x-axis, and that would be why, because the R step does not yield any answers. Then we do the A step. Our denominator is just x minus 1 now, and we take that and set it equal to 0, and we figure out that we're going to have a vertical asymptote at x equals 1. And so once again, you can see that in this graph. We do have a vertical asymptote right here at 1. That's where our break in the graph is. Of course, we are skipping the T step this year, so we go straight to the E step. So we look at the leading term of the numerator over the leading term of the denominator. Remember, from the simplified equation. So the leading term on top is just 2. It's the only term on top. And then the leading term in the denominator is x. And so this does make it a bottom-heavy equation. We do have a higher power on the denominator, and so that means we have a horizontal asymptote at y equals 0. Because if you'll remember from day 1, all bottom-heavy equations have a horizontal asymptote at y equals 0. And so we can see we have a horizontal asymptote. That's where the two edges of our graph are getting flat and getting really close to 0. And last but not least, the y-intercept. So once again, I'm going to plug 0 in for x, just like I did the y-intercept in every unit. But remember that I'm going to plug it into the simplified equation. So I plug 0 in for x into the simplified equation, and so I get 2 over negative 1, and so my y-intercept is negative 2. And I can see that on my graph as well. And remember that, once again, you don't have to draw these graphs. You don't have to know how to create them for yourselves. We are simply looking at what these characteristics would look like on a graph, what it is that these SHRATEY steps are telling us about our function. Okay, so that's the first example. So to summarize, to how to locate a hole, okay, the first thing you're going to do is you're going to do the S step. You are going to factor your equation and you are going to reduce it. okay? The x-coordinate for the hole is wherever that vertical asymptote would have been. Okay, so if I gave you an equation, let's say that we had an equation that had already, let's just say, factored, and I had, x plus 5, x minus 1, and x minus 2, x minus 1. So it would be the x minus 1 that would cancel. And so that means for this second step right here, x equals 1 would be the x-coordinate for our hole, because x equals 1 is where that vertical asymptote would have occurred. Okay, so our x-coordinate would be 1. And then we take that x-coordinate and we plug it into our simplified equation to find the y-coordinate. So our simplified equation is now just x plus 5 on top and just x minus 2 on bottom. And so I would plug that x equals 1 into this equation. So if I plug the 1 in here, I get a 6 on top and a -1 on bottom. And so the y-coordinate would be -6. And that would be where I would plot my open circle or my hole. Okay? So example 2, I want you to take a look at the graph real quick. This would throw some people for a loop if they are graphing their equations first and they're not understanding the SHRATEY analysis steps, or they're not doing those steps first. They would graph it, and on the graph, you would actually not see the hole. You notice that even in Desmos, which graphs a lot of things, the hole doesn't show up. In a calculator, the only place you're going to see that hole is in the table. You're not going to see it on the graphing screen if you graph these things in a calculator. So you have to be able to figure out that it's there. But if you look at the rest of the graph, it looks awfully simple. There's no other breaks in the graph. It looks like a line. And there's a reason for that. And that's because if I did my S step, I notice in my numerator, the first thing that happens is there's a 3 that would pull out. And that leaves me with x squared minus 4. And if I continue my simplifying, my factoring, x squared minus 4 is a difference of 2 squares, and it factors as x plus 2, x minus 2. And so I see that the x minus 2 is going to cancel. So that's the reason I have a hole. And it tells me that the x-coordinate for that hole would be at 2. But it also leaves me with a simplified equation of just 3x plus 6. That means it leaves me with a linear equation. So the first thing that I want to do is I want to use that linear equation to find the y-coordinate for the hole. So I take x is 2 and I plug it into my new, very simplified equation, and I get 12 for the y-coordinate of the hole. So that's why the hole is at the point 2, 12. But because my simplified equation is now just a line, I don't have to continue with any other of the Rady steps. Okay? It's not rational anymore. So that means that 99% of this graph is going to behave as a line. It is literally just going to be graph a line and remember to put that hole somewhere on the line. Okay? Now, if you want to, you can go ahead and technically, when you find the x-intercept and the y-intercept for a line, you're still doing those steps of Rady. So you could still do the r step and the y step, but you don't have to. I mean, you can find your x-intercept and your y-intercept the normal way. You can tell right here, there's your y-intercept, because of course I put my linear equation in slope-intercept form. So there's my y-intercept right there at 6. And if I want to know what my x-intercept is, I of course just set my equation equal to 0. And so I figure out that my x-intercept is at -2. But that's only if you're being asked to find those pieces of information. You would not need to do, obviously you're not going to do the T step because we're skipping it this year anyway, but you would not need to do the E step. There is no rational end behavior to this function because it just became a line. Okay. And the last example for today, nothing too funky, no 3 branches. It is possible to have multiple vertical asymptotes left in your graph, but that is not something that is common, mostly just because that's throwing too many difficult concepts into one equation, but also because that would require that you have a cubic equation or a cubic polynomial in your numerator or denominator, and we are not dealing with cubics, and you really won't deal with those even in pre-cal next year. So same thing, we start with our S step. I'm going to pull the 2 out of my numerator first, leave me with x squared minus 1. And go ahead and factor the denominator, which is x plus 3, x minus 1. Of course, continue my factoring. X squared minus 1 factors as x plus 1, x minus 1. It's a difference of 2 squares again. And so it's going to be the x minus 1. That cancels. So that tells me that my whole will have an x coordinate of 1 because of that vertical asymptote canceling out. My new simplified equation has the 2 and the x plus 1 on the top, and it has just an x plus 3 in the denominator. And so to find the y coordinate for the whole, I'm going to plug this x into my simplified equation. So plug 1 in. So I have 2 times 2 in the numerator, which gives me 4, and 1 plus 3 in the denominator also gives me 4. And so that tells me that the y coordinate is also 1. Okay, so I have located my whole, and I have my new simplified equation to do the rest of my analysis steps with. So now I can find my roots by taking my numerator, and you can include the 2 if you want to. It's not going to have any bearing on your solution because your first step would be to divide the 2 out of there anyway. So you really are just solving for where x plus 1 is equal to 0. And so you get an x-intercept of -1. And so you can see that right there. There's your x-intercept. Then you do the A step. Your new simplified denominator just has the x plus 3 in it. So you set it equal to 0 and solve it, and you get a vertical asymptote of x equals -3, which once again you can see that as well. Skip the T step, of course, this year. Then you look at the E step, and the E step requires that you're able to understand that this 2, let me switch colors so I don't have to rewrite the whole equation, this 2, it would normally distribute through those parentheses. And so your leading term in your numerator would actually be a 2x. And then the leading term in the denominator is just the x, because there's nothing that would have needed to distribute or anything happen down there. So this is still a balanced equation. Remember that balanced does not have anything to do with coefficients. Balanced has to do with the degree or the exponent or power. So we have linear on top, we have linear on bottom, and so it is still balanced. And so we are going to have a horizontal asymptote. That horizontal asymptote will occur wherever this fraction reduces to. So if I reduce 2x over x, it reduces to 2. And so that means my horizontal asymptote would be at y equals 2, which once again, you can see that. Let me erase this. So you can see your horizontal asymptote is sure enough at 2. Both edges of your graph do curve and get flat and approach 2. And then the last step is the y-intercept. Plug 0 in. Remember that we have to do everything in the simplified equation. So I'm plugging 0 into my simplified equation. So I have 2 times 1 in my numerator, and I have 0 plus 3 in my denominator, and so my y-intercept is at 0 2/3. And so I can see that right there. Okay, so those are all of the SHRATEY steps for that graph. So your practice problems, your last practice problems, are these 3. Remember that you do not have to graph. If you want to graph these in Desmos or a graphing calculator just to have a reference to look at as you do the SHRATEY steps, that is perfectly helpful and understandable, but don't feel the need to graph them for yourselves, okay? So just simplify, find the holes, and then do the RATE analysis steps. Congratulations. We are all very sorry that we don't get to see you guys to tell you goodbye for the end of this school year. So keep in touch and let us know how you're doing, and take care.